Hello and welcome to part 7 of From Zero to Hero Teaching You C++. In the last video we talked about references and pointers. In this video we'll be talking about the syntax of pointers and the interesting benefit of using pointers and references with objects that inherit from the same base class. So we know that a reference is defined by putting an ampersand after the type. A pointer uses a star or an asterisk depending on what you call it. So for example, if you wanted to make a car pointer, it would look something like that. Just a side note, most programmers like to put a lowercase p before the name of a pointer just so that it's quicker to read it when looking over code and know it's a pointer. So now that we have a pointer, how do we make that point at something? Remember that the ampersand that we used for a reference, well, we use that again here. This time it goes before the object that you want to point at. The ampersand in C++ basically means the memory address of this object. So how do we use a pointer? We know from a previous video that to access a function from a class, you use the dot operator, like bike. For references, this is the same. However, with pointers, something changes. Instead of using the dot, we use this. Why it looks like this as opposed to a dot, honestly, I'm not sure. It's just one of those things you have to remember. Okay, so they're a little different, but not too much. You can, however, dereference a pointer, something you cannot do with a reference. It's the act of getting the actual object that you are pointing at instead of using the pointer. So to call print, for example, using the pointer, we would call it like that. However, we can put a star in front of the car, and then it will turn into a dereferenced object, and we can use the dot operator on it, like that. You'll be asking, why would you want to do this? Well, one use case for this is if you want to copy the object. This will copy all of the data from the object that the pointer is pointing to, meaning that you can change the copy, or the original, and the other won't be affected. That's all the syntax for a pointer that's really needed. So now we'll move on to using these with inheritance. You see, when you have, for example, a car and a bike, which both inherit from vehicle, you can make a vehicle pointer, or reference, that is set to point at one of these inherited objects. Let me give you an example. Now this code will work. It's hard to understand why, but if you take out all of the extra functions or variables that are specific to a car and a bike, then they are still vehicles. So although doing this will mean that you cannot call specific functions that are not present in the base class vehicle, you can call any function that is present in it. If you define a function in an inherited object, like we have done with the print function in car and bike, the code will use that function, not the one from the base class. This is useful as it means that you can group together similar objects to be able to act on all of them in one loop. let's put all of our cars and our bikes into one vector of vehicle pointers and then loop through and print all of them. So now that we've filled up our vehicles vector with all of our cars and our bike, we can change our print cars function to be print vehicles. That takes a vector of vehicle pointers. We can now remove our bike print code. And when we run it, we should get the same result. So as you can see from the output, it is the same, but all of the print functions are done in one place. So what happens if you have a pointer to an inherited object and you want to call a function that is not present in the base class? Well, you can do that. You can tell the code that it's actually a pointer to your inherited object. This is called a cast. This code would work provided we actually made a function that's only present in bike. So just to briefly describe what you need to do here to get this to work. P example is a vehicle pointer. Putting this bike pointer in brackets before P example will tell the compiler that it's actually a bike pointer. And then you will be able to call functions that only exist in bike. You have to be very careful with casting though, because if it's cast to something that it's not able to become, it can be problematic. There are better ways of casting known as a static cast and a dynamic cast, but this will do for now. You can actually cast many types. For example, this code will convert the float into an integer just fine. So that's pretty much it for this video. Hopefully you can see the benefits of pointers and references and understand the differences between them. This video marks the end of what I would consider to be the basics of C++. There are some topics that I've chosen to miss out, for example switches, arrays and debugging. So the next video will be a fill in the blanks video. With this knowledge though, you should be able to create all sorts of programs, calculators, databases, card games.